All right. So this is going to be another star review. This one might be a little bit, I don't know, might take 10 minutes for the front, 10 minutes for the back. So we are dealing with quadratics. Yes, you should have your video on every day. We're dealing with quadratics, okay? Earlier, I asked somebody what was the quadratic parent function. They said y equals mx plus b. This is the linear function. If it's a quadratic, it's going to have power of 2. Or it could be f of x, x to the power of 2. All right. The transformation of the parent function is how it moves, okay? If you look at these three, sorry, let me focus my camera. If you look at these three, these are the parent quadratic function. Notice the vertex is sitting there nicely at the origin. What we're going to do is we're going to start looking at how we can change the parent function in many different ways, okay? So if you look here, it kind of tells you. If you see a number in the front getting multiplied, that's how you reflect it or stretch it or compress it. If you see a number that's added or subtracted in the parentheses, that's how you shift it right or left. If you see a number getting added to the back here, that's how it shifts up or down. So remember, if this number is getting added somewhere outside of the parentheses, it shifts it up or down. If this number gets added, or it could be subtract, but notice this one's inside the parentheses. This one's outside the parentheses. This moves it right or left. However, this a in the front is a number that gets multiplied, and that's how we can stretch or compress or reflect it. So the other name for reflect is a flipped parabola. The other name for stretch is a skinny parabola. The other name for compress is a wide parabola. Okay? So now I'm going to show the difference between what the equations look like. And technically, if you're watching the video from home, this a right here isn't really right. It's just like any number. 1 over any number has to be like a fraction right here, okay? So, like I said, this right here is the perfect parent function. However, if I want to get a reflection of the parabola, which means it's going to flip, I have to take the f of x, which is the original function, and put a negative in front of it. Then I'm just going to kind of estimate, freehand draw. I'm not going to perfectly draw. But you'll notice that the parabola will now be upside down because it's reflected. Okay. Now, if I want to get a stretch, which is make the parabola skinny, I need to stop feeding it. I'm just kidding. If you want to make your dog skinny, stop. No, that doesn't. Don't ever stop feeding your dog. That is wrong. I should not say that because I'm putting this on YouTube. I love puppies and I love to stuff them and make them little fat puppies because they're so cute. Anyway, if I want to stretch, which is make more skinny, I would have to make sure I had a big number. And when I say big number, some people say, oh, 5 is not a big number, but it is bigger than a 1, okay? So if I want something to be more skinny, you see how first it was the normal parabola and now it's more skinny. It's like in between. That's how I get stretch. And if I want to compress, I would take my function and I would make a smaller number in the front. Smaller number like 3 over 4, 1 over 2, 1 over 4, because that would make it wide. And this compress is for a vertical compress. This stretch is for a vertical stretch. We are not talking about horizontal stretches or horizontal compressing in this video. Okay. So now let's take a look at how to move the parabola, like kind of like it's right here right now. I'm going to move it to the left, to the right. It gives you a little bit of information right here, but sometimes it makes more sense if we actually see some numbers, okay? So if I want to move my parabola, and when I say move my parabola, it's kind of like looking at the vertex. Right now the vertex is at 0, 0. If I want to move my vertex over, then I would need to make sure that I have something going on inside of the parentheses, and let's use -3 right here. I forgot that somebody was trying to join the Zoom. Sorry, let me see. All right, so if I want to shift my parabola to the right, I need to put x -3. Now be careful, because x -3, you would think it's on the negative side, but these parentheses cause the opposite effect, which means now my vertex will be here. It's still pointing up. It's not wider. It's not skinnier. It's just simply moved over to the right. So this one right here would be my x -3. However, if I want to move it over here to this, would be x +3. So if I want to move it to the left, then I would have an x +3 in there. Remember, +3, usually positives are over here, but when you put it in parentheses, it causes the opposite effect, which means it moves it to the left. All right. Now, the only time that we have an opposite effect is when it's in the parentheses, because over here, I'm going to start shifting it up or down. If I want to shift my parabola up, nothing's in the parabola is going to change. It's going to be something getting either. If I want to shift it up, it would get added on the outside of the parentheses. So remember, and I'm looking at the vertex. The vertex was at 0, 0, but now it's a +4 on the outside, so the new vertex is at +4. So all of these points get moved up 2, 3, 4. This point here, 1, 2, 3, 4. If you want to be exact, when you're plotting points, you would basically just move all the points up. Sometimes people think this parabola looks smaller. No, the parabola should be the same size. It's just basically if I took my parabola and moved it up. Now, if I want to move it down, from the 0, 0. Nothing on the inside would change. I would just put a -4 here. And remember, even this point gets 1, 2, 3, 4. This point, 1, 2, 3, 4. This point, 1, 2, 3, 4. Every single point gets moved down. Will create our new parabola. Okay. Also, for a side note, I'm just about done with the transformations here, but for a side note, on the star, they like to mix 2 of these transformations. They're going to take 2, they're going to mix it together. So they're going to do something like this. They're going to say, I want to put, let's just say we put 5, then f plus 9. They're mixing 2 things together. So the 5 does something. The 5, if you look here, is a vertical stretch. However, this x plus 9, which is inside, remember, normally positive is on the right side. But since it's a in the parentheses, that's going to be shifting it to the left, is a left shift. A lot of times on the star, they will do 2 different shifts. It's not just going to be 1 change. It's going to be 2 changes. All right.